Okay, let us begin. Measurement and scientific notation, here we go. So, we live in Canada, and Canada has the vast majority of the countries, except for two, Bangladesh and some other little country that, nobody really cares about, use not the metric system. Bangladesh and the United States. Those are the only two countries that don't. Every other country in the world uses the metric system. The metric system is also called the SI system because the people who named it backwards. That would be the French. The Système International. These are the units that we use for science, regardless of where you are in the world. Even if you're in the States, these are the units you're supposed to use. When we measure things, what are the base units that we use? For length, we use what is the base unit for measuring length? Meter. And technically speaking, meter is spelled M-E-T-R-E. Even though on your driver's license and stuff, it would probably give you your height. Does it give it in meters? Is it feet and inches? Is it meters or is it centimeters? I never know. Meters is the one that we typically that we use in physics. It's the standard scientific base unit for measure, and we use the symbol M to represent the meter. None of this is rocket science or new, I would hope. When we measure mass, we're going to talk about the difference between weight and mass. I'm sure at this point in your brain, those are interchangeable. They are not, actually, but we'll differentiate those later. When we measure your mass, or if I asked you for your mass in the International Scientific System, what units should you use? Believe it or not, it's not grams. It is, in fact, the kilogram. Even though the kilogram isn't the base, like the gram is the base unit there, kilogram is what we use for mass, for everything in physics. Time is measured in seconds. Obviously, seconds is the letter S. When we talk about things like speed, if I'm asking you how fast you're going, you might give it to me as kilometers per hour, but believe it or not, those are not the units that we use. The base unit that we use isn't the kilometer and the hour. It's made up of the equivalent units from these ones. So instead of the kilometer, we're going to use the meter, because meter is length, not gram. And instead of hours, we're going to use the other time unit, seconds. So speed is going to be a measure of meter per second. So M/S. Hello, gentlemen. Let me get you what you need. Measure speed in grams. Gentlemen, go be an animal for a week. Same questions. Be an animal for a week. A dog. Nice. Good choice. Grams?
No, it's the time it takes for you to move your mass from one area.
Well, the time it takes to move your mass. But the point is that you're moving your mass a distance. Okay, force. Force is not something that we've talked about. You've probably not talked about this yet. You might have an intuitive understanding of it. Did you learn it somewhere else? Don't say it if you did. Yeah, he did. He learned it somewhere else. We have a whole unit to talk about forces, and I'll just kind of briefly mention them here. A force is something that causes motion in something else. Often. That's one way to think about it. A force is, another way to think about it is, if a large enough one was applied to you, it would hurt. Anything that might do that, you could think about as having a force. Force we name after, yep. Maybe Newton. Yeah, the same thing. Yes, you guys have seen this before. Forces are measured in newtons for exactly the reason you might think. That guy, Sir Isaac, who did some stuff with apples and falling, we're naming them after him. Forces are measured in newtons. We'll talk more about them next chapter. And energy. Energy is something you would have talked about in Science 10. We measure those in joules. The English physicist, use the capital letter G. We have base units for everything, and then we start to convert our way between them. If we want larger or smaller versions of these units, the beauty of the metric system is such that we're going to use the base and we just change the prefixes. So instead of meters, we might have kilometers, or instead of, if we want to go smaller, we might have the centimeter, but we've always got this base to work with. If we want to go smaller than the kilogram, we might go down into the gram. If we want to go bigger, we might go into megagrams. It's a thing. We'll talk about what that is. Not something you hear very often, but it is a valid unit of measure. And this is the power of the metric system, because all of these prefixes, examples being micro, milli, centi, kilo, mega, and I do actually have to give you your formula sheets today, because there are more of these prefixes on the front of that, and I'll do that in a second. All of these prefixes just mean different multipliers. I'll show you what I mean. If you have a kilogram, what does that mean? 10 to the power of 3 or 1,000, right? So kilo, we did it right there. We said that the kilogram was kg. That prefix, the symbol we use for kilo is the letter K, and it has a numerical meaning. Kilo means that you have 1,000 of something. So if you have a kilogram, it means you got 1,000 grams. Sienna gave it to us in scientific notation, 10 to the power of 3. And again, the beauty of the metric system or the international scientific system is we're just going to jump around with powers of 10. The imperial system, you don't jump around by powers of 10. If you want to go smaller than feet, now you have to use what? What's the unit smaller than a foot? An inch. What's the unit bigger than a foot?
Miles.
Well, smaller than miles. A yard. What's bigger than yards but smaller than miles in the imperial system? Does anybody know? It's called a furlong. And then bigger than furlongs, you get miles. And there's no consistency between these things. The numbers are all wacky, and this is why we don't like using them. When we're dealing with the metric system, everything is just multiples of 10 of these fundamental base units. Kilo, the first one, being 1,000 or 10 to the 3. Centi, where are you familiar with centi? Centimeters. It's probably the only place you're familiar with it, but we use it other places too. You could have centigrams. Often that's a unit that gets used in chemistry when you have small but not really small amounts of things. But centi, often in the centimeter, centi is C, and it means what? It doesn't mean 100. How big? So why do you say 100, Sienna?
Centipede.
Sorry?
Centipede has 100 feet.
Because a centipede has 100 feet, or a centimeter has, there are 100 centimeters in a meter. So let's take it the other way. If kilo meant 1,000 grams, a single centimeter is how much of a meter? 1/100th. So the fraction. So it's not 100, it's 1/100th. Or if we're going to use scientific notation for this, 1/100th is 10 to the negative 2. The other one you're probably fairly familiar with, I would hope, is the milli, as in the millimeter. If centi is, if there was 100 centimeters in a meter, so 1 centimeter is 1/100th, what does milli mean? If you can make that extension for me, which is what you said too, Violet. 1/1000th. There are 1,000 millimeters in a meter, so 1 millimeter is 1/1000th of a meter. And then there's two other common ones that we use in physics, and we don't use a lot beyond these, but we're going to show you more that we use. Micro. Does anyone know micro? It is a U-looking thing. It's actually supposed to be a fun-looking M, but it often looks like a U. It's a Greek letter. That is the Greek letter mu. We use it for a few things in physics. One of them is for the prefix micro. So if I wanted a micrometer, for example, it would look like this. Micrometer. Those of you who have taken chemistry already, how big is a micrometer? Or how much of something is a micro? Does anybody know? Do you remember? Nope. Micro is quite small. Micro is 1/1,000,000th. Or 10 to the negative 6 of something. Well, 10 to the 6 is a million, so 10 to the negative 6 is 1/1,000,000th. Whatever. It's only the Friday of the first week of school. I don't expect you to make those jumps. And then if I did micro on the bottom end, mega is probably what? Or if you're into computing, then mega means what? Megabyte, megabit. How many megabits, or how many bits are there in a megabit? 1,000,000. 1, 2, 3, 4, 5, 6, or 10 to the 6 of something. And mega is exactly what you would expect it to be, except it's not lowercase m. Mega is big, so it gets capital M. I was going to try to avoid handing these things out, but I'm going to hand them out now anyway, because you need the bottom of the front page. There are 4 prefixes. Some of them are uncommon, but they show up places, and so I'm going to introduce you to them at least. This is your formula sheet. You will get a formula sheet on if you have access to a formula sheet, on every test, quiz, piece of homework that we do. And if you look at the bottom, the whole bottom, maybe 8, 6. Rounds, 2 for you guys. Yours, 1, 2, 3, 4. 1, 2, 3, 4. There are a whole bunch of totally valid, slightly obscure prefixes that we use to represent different values. And I'll show you how to use them. They start really big and get really small. We've got the iota, the peta, the tera, the giga, the mega. There's a chunk in here that are going to be familiar to those of you who are into computers or computing. Terabits, terabytes, gigabytes, megabytes, kilobytes, bytes. We don't talk about bytes anymore because those are too small. But lots of these show up in computing. There's petabytes, and I think there's more than that too yet now. Kilo, hecto, deca, deci, centi. We don't really use deci or deca, but they show up. Milli, micro, nano, pico, femto, and yocto. These ones, femto, pico, and nano, show up in physics almost exclusively. They're really, really quite small, and every other subject seems to be really scared of dealing with the small things, except for physics. We talk about those particles. There's a whole field of physics called particle physics that deals with things on the nano, pico, or femto scale. And so what we're going to do today is we're actually going to practice just using these things to convert from one unit to the next. If you're in chemistry, you'll see this there. If you've already taken chemistry, you'll have done this already. I'm going to show you how this goes. There is a method. The name of this method, different teachers have different names for it. I'll put it over here on the side. I was taught that this is called the factor label method. For unit conversions, hands up if you're in chemistry right now. Okay, there's a bunch of you. Chem 11 specifically. There's a whole section of Chem 11 where you're doing like mole conversions. You're going to convert from density and volumes and masses, and you're going to convert between all of these things. Really, that entire unit is just an exercise in unit conversions using this method. It's going to look a little different because the units you're going to use are weird and unfamiliar. Like, I don't know if you know what a mole is yet, but you'll learn. But all it is converting between units. We're going to do that just using the metric system. Chemistry brings in a whole bunch of other things. So here's what this looks like. The factor label method looks like this. If I wanted to convert 165 millimeters to meters. That's not a difficult conversion for a lot of you to do in your head. I would assume that some of you could crank this out fairly easily, but I'm going to show you what this looks like using this method so that you have a framework to do some of the more ridiculous questions I'm going to ask you to do. So here's what it looks like. You always write down what you're starting with. So we're starting with 165 millimeters. And what we want to do is we want to convert this thing by multiplying this with a whole bunch of fractions. We actually, in this case, we could do it with one fraction. Is there a nice conversion between the millimeter and the meter? Is there a straight line that we can draw between those two sets of units? Yeah. The meter is the base unit. The millimeter is just the base unit with a single prefix on it. There's a nice line that we can draw between those things. So we set up the fraction. We're going to multiply this thing by a fraction. What's the fraction going to be? On the bottom, you put whatever you're trying to get rid of from the top up here. So the millimeters are in the numerator here, because technically speaking, this would be over 1. You put in the denominator the thing you're trying to get rid of. We want to get rid of the millimeter. And for those, the math skills would suggest that when I multiply across the top and multiply across the bottom and then divide, or you can look at it as cross-simplifying, if something shows up in the numerator and in the denominator, it's going to cancel. And then we put what we want to convert into the numerator, because there's nothing to cancel with it. That's all that's going to remain. And now all we got to do is figure out what are the conversions that we can use to get in here. And there's two ways that you can set this thing up. You can either use the scientific notation for it, or you can use these values here. The 1 millionth, the 1,000th, 1/100th, 1,000, million. We can use those values directly, or we can use the scientific notation. I will show you both, and I don't care which one you're more comfortable with. Pick one and roll with that. So if I've got 165 millimeters, I'll show you the scientific notation first. What we're going to do is we're going to take milli in the bottom, and we're going to replace that prefix milli with its scientific notation piece in the numerator. So milli means 10 to the negative 3, which you do not need to memorize because you're going to have your formula sheet with you. So I'm going to put 10 to the negative 3 in the numerator, and I'm going to put a 1 in the denominator. 1 millimeter is 10 to the negative 3 meters. And so now what's going to end up happening here is when I multiply these fractions together, that's going to